In this video, I'm going to talk about the trigonometric identities, which are equations that involve the trig functions that are going to be true for every value of the variables involved. And there are identities that we've already covered, starting with the reciprocal identities. So the reciprocal identities are just if we take the main trig functions, sine, cosine, and tangent, how can we write those in terms of their reciprocals? So for sine, I can say, well, sine of theta is equal to, if I talk about it in terms of its reciprocal, 1 over its reciprocal cosecant of theta. Cosine of theta I can write as 1 over secant. Tangent I can write as 1 over cotangent. And I can also do the reverse because sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. Then we also talked about the quotient identities. So the quotient identities are just talking about tangent and cotangent and how we can talk about them in terms of sine and cosine. So tangent of theta is sine over cosine, and cotangent of theta is cosine over sine, which makes sense because this is the flipped version. Oh, I don't know. This is the flipped version of that, which makes sense because cotangent and tangent are reciprocals of each other. We also talked about the even and odd identities. So we know that sine and tangent are odd functions. We know, so we know sine and tangent are going to be odd functions, which means that if I plug in a negative input, a negative theta, it's going to give me the same thing as plugging in the positive version, but I would get the opposite. We talked about that a lot. So these are odd functions, and obviously their reciprocals are the same, so cotangent and cosecant are also odd. And then we talked about cosine and secant being even functions, which means that it doesn't matter if I plug in a negative angle, I'm still going to get the same thing as plugging in the positive version of that angle. So if it's negative or positive, it's going to give you the same answer for cosine and secant. Tangent and sine and their reciprocals will give you the opposite if you plug in the negative version. The new identities that we're going to talk about right now are we're going to start with the Pythagorean identities. So the Pythagorean identities come from the unit circle. So if I am thinking about some coordinate on the unit circle, x comma y, I can create a right triangle and I can say, okay, well, this side is x and this side is y, and I know that the hypotenuse is 1. So what I could say, Pythagorean theorem, what that says is I can add x squared plus y squared and say that's equal to 1 squared. So I can say x squared plus y squared is equal to 1 squared, or just 1. I know that on the unit circle, the x value is always equal to cosine. So I know that this is actually cosine of theta squared. And I know that y is always going to be sine. So I could say, well, this is sine of theta squared instead of y squared, and that's equal to 1. That's my first trig, my first Pythagorean identity. So I don't write it like that, though. I write it like this: cosine squared of theta plus sine squared of theta is equal to 1. And this would be my first Pythagorean identity. So I'm going to write it in this box here. Write that first. That's my first one. The second Pythagorean identity that I have is cotangent squared of theta plus 1 is equal to cosecant squared of theta. And this actually stems from the original Pythagorean identity that I have. So if I take cosine squared of theta plus sine squared of theta equal to 1, I can edit this in some way to be that second Pythagorean identity. And what I can do if I want to go from cosine squared of theta to cotangent squared of theta, what would I do? I would have to divide by sine squared of theta. Okay, well, if I divide everything by sine squared of theta, will I end up with this? Sine squared of theta over sine squared of theta is 1, yes. 1 over sine squared of theta is cosecant squared of theta, yes. So that's what I do. In order, if I wanted to derive this second Pythagorean identity, I could start with my first Pythagorean identity and then just divide by sine squared of theta each term. My third Pythagorean identity is 1 plus tangent squared of theta is equal to secant squared of theta. And I can derive this also from my original Pythagorean identity, which is cosine squared of theta plus sine squared of theta equals 1. And if I wanted to go from cosine squared of theta to 1, what could I divide by? I could divide by itself, cosine squared of theta. Well, if I do that to everything, well, I end up with this Pythagorean identity. Sine squared over cosine squared is going to be tangent squared. And 1 over cosine squared is going to be 1 over secant squared. So yeah, that would be how I would derive the third Pythagorean identity. And those are the 3. We're also going to add cofunction identities. So those say that if I do sine of pi over 2 minus theta, it's going to give me, I'm just going to tell you, cosine of theta. If I do cosine of pi over 2 minus theta, it's going to give me sine of theta. If I do cosecant of pi over 2 minus theta, it's going to give me secant of theta. And if I do secant of pi over 2 minus theta, you probably could guess what the pattern is. This would be cosecant of theta. If I do tangent of pi over 2 minus theta, it's going to give me cotangent of theta. And if I do cotangent of pi over 2 minus theta, it's going to give me tangent of theta. So those are new ones too.